Hello, and welcome to Astronomy 100. In this video, we're going to continue our discussion of stellar evolution. And remember, the idea of stellar evolution is really chronicling how stars form, how they produce their energy, why they eventually die, and what they become after their death or following their existence. And so in the last video, we started talking about how the HR diagram plays an important role in understanding stars of different stages in their evolution. In this video, we're going to concentrate on the concept of where do the stars come from. And let's go ahead and get started. The first thing we should do before we discuss where the stars come from is we need to remind ourselves of what the stars are made out of. And to put the numbers I'm about to show you into context, let me put up these numbers here. Our sun is actually a very, very big object, but it's not really a single thing. It's a collection of many, many atoms. And it turns out that a star like the sun is a collection of about 10 to the 57 atoms total. Remember, that's a 1 followed by 57 zeros. So it's a lot of atoms, which should make sense. Atoms are small and stars are big. So the sun is a collection of many, many atoms. Those atoms collectively equal a mass of 1.99 times 10 to the 30th kilograms. And so what that means is that the mass of all those atoms put together equals this many kilograms. And here on Earth, 1 kilogram's worth of anything that's a mass of 1 kilogram weighs 2.2 pounds. So the total number of atoms and the mass of the sun are shown for you here. In a previous video, we were talking about how we can use the spectral lines of the sun to figure out what the sun is made out of. And I showed you a list of some of the materials that the sun is composed of. What I'm going to do now is I'm going to take that list and really boil it down to what's the most important part, or the essence of the idea. On the left here, we have the element that we're considering, which is the atomic element that we're talking about. The middle column is by number, and what that means is what percentage of this number would that element occupy or be composed of. And then the third column is by mass, and the idea is what percentage of this total mass would that element be. So the single most abundant thing that the sun is composed of is hydrogen by far. Hydrogen makes up 91%, or a little more than 91% of all the atoms. So what this means is 91% of 10 to the 57 atoms are hydrogen atoms. And the mass of that total amount of hydrogen makes up 71% of the mass of the sun. Now, the second most abundant element that the sun is made out of is helium. And it makes up of not quite 9% of the total number of atoms. And the 9%, or just shy of 9% by number, ends up being a little more than 27% by mass. Now, if you use math and add these two numbers together, you get 99.9%. And what I want you to notice is that 99.9%, or practically 100% of the sun's overall material, is composed of two elements. And of those two elements, hydrogen and helium, hydrogen makes up the majority. So when you think about what the sun is made out of, you could really get away with saying that the sun and all stars are really giant collections of hydrogen atoms. Throw in a little bit of helium to round it out. And then, of course, 99.9% is not 100%. There's 0.1% of a difference. Now, that 1/10 of 1% is all the other atoms that make up the sun. And there are 72 different atoms that make up that all others. The sun is made up of a total of about 74 different elements. One of them is hydrogen, one of them is helium, and then 72 other things make up the all others. And what I'll show you is just sort of the top 10 altogether. So when we add hydrogen and helium plus the next 8, this is what we have. So the third most abundant element is oxygen, the fourth most abundant is carbon, the fifth most abundant is nitrogen, and so forth. But remember, 72 different elements make up 1/10 of 1% of the total number of atoms in the sun. So you could say that the sun is made up of 74 different things, but in reality, it's made up almost entirely of hydrogen with a little bit of helium and a tiny amount of many other things. Now, the reason why I'm pointing that out is because if stars are made up of almost entirely hydrogen, one of the questions, of course, that comes with that is, where does all of this hydrogen come from? In the world around you here on Earth, there are many different types of elements. You could think of what you are made out of. You are made of mostly water. Water is hydrogen and oxygen, but you have carbon that makes up part of your DNA, the calcium in your bones, the iron in your blood. The world around us, this desk is made out of a wood product, which is a lot of carbon. Rocks are made up of carbon and silicon and oxygen and things like that. But the one thing that becomes apparent is we are not living in a world of lots of hydrogen. There is some hydrogen, obviously. The water on Earth is composed of hydrogen and oxygen. But even though the water of the Earth covers the majority, or 2/3 of the surface of the Earth, that surface layer only goes down so far. The Earth itself, as a terrestrial rocky body, is made up of things like iron and nickel and carbon and oxygen and silicon and things like that. So the concept is the sun is made up of lots and lots of hydrogen. Stars are made up of lots and lots of hydrogen. Where does that hydrogen come from? It's clearly not all around us. So the astronomers of about a century ago, maybe 120 years ago, they were a little baffled by this. It seems like stars are made out of an element that doesn't seem to be very abundant. And some of this would be answered very slowly over time with new discoveries. But let me show you one way that we can show how we're being deceived a little bit. This photograph here is the constellation of Orion. It's familiar. We've seen it several times throughout this course. And what you'll notice in this photograph is there are lots of stars. But the one thing that you'll notice that seems to be more common in this picture than anything else is the lack of stars. There are dots of light here and there, but notice how much black there is. Of course, we call that space. Space is called space for a reason, because it implies emptiness. So in our universe, it seems like there are stars here and there, but there are lots and lots of places where there seems to be nothing. And so the astronomers were a little confused because stars themselves are made up of lots of hydrogen, but there doesn't seem to be any place where that hydrogen comes from. How do you get something from what seems to be nothing? And the trick is to look at this region of the sky in a slightly different way. So what astronomers can do is they can use filters. And what a filter simply does, the nature of any filter, is to allow certain things while blocking other things. And in astronomy, what we use is a special type of a filter made out of glass. And this filter is attached to a telescope so that when the telescope allows light to come through it, it allows only a certain wavelength of light. So you can block out other wavelengths while allowing only certain wavelengths. And the filter that can be used is one that allows only the wavelength that's associated with hydrogen. Hydrogen makes only certain colors because of the electrons and the energy levels, what we talked about in a previous lecture. So when you attach these hydrogen filters to the telescope, what happens is this very same part of the sky that you see here turns into this. So notice exact same stars. Let me go back. Exact same stars, but notice that it brings out a detail that you didn't see in the previous picture. All of the reddish material, the glowing red material that you see, comes from hydrogen. This is the color that is associated with the element hydrogen. So what this reveals is that the space between the stars is not as empty as you might think. There is hydrogen between the stars, and you'll notice by the sizes of some of these clouds, it seems to be quite a bit of hydrogen. So rest assured, the material that makes up the stars themselves is actually present between the stars. There now seems to be a source for all of this hydrogen that makes up all the stars. This sort of spawned a new area of astronomy because what we now have is material between the stars, and we actually give this material a name. It's called the interstellar medium, and the term interstellar medium, the word interstellar means between the stars, and the word medium in this case is material. In the world of physics, a medium is a certain material, like water is a medium, dirt is a medium, air is a medium, and so forth. So the interstellar medium translates into the material between the stars. And we abbreviate it frequently using the acronym ISM, so the interstellar medium. So for almost a century, the astronomers have been really paying careful attention to this material between the stars. And in this photo here on the right, you can see another example. This is a cloudy place in space, lots and lots of stars, but you'll notice that there seems to be quite a bit of this colorful gas. And again, this is the color from hydrogen. So the interstellar medium is something that we've been studying for quite some time. And what we now know is that the interstellar medium can be broken down into really two types of material. There is material in the form of gas, and then there is material in the form of what we call dust. And we'll talk a little bit more about dust in a minute. It's not quite as simple as the word seems. So this material between the stars is composed of gas and dust. The one thing that's not very obvious in these pictures is what is the quantity of this material? Is it a very dense material, lots and lots of gas, or is it kind of sparse and thin? And after studying it, what we now know is we can break it down into a couple different ways. The material between the stars is very thin. The space between the stars is almost a perfect vacuum. A perfect vacuum would be if we had a volume where we take out everything. There's not a single atom or molecule left inside of a certain space. So if space was absolutely empty, it would be a perfect vacuum. Well, how close to absolutely empty is space? Let's break it down. The gas that we find between the stars makes up the majority of the interstellar medium. So 99% of what is present between the stars is in the form of gas, and it's mostly hydrogen and helium atoms. Now this shouldn't be surprising because the stars are made out of hydrogen mostly with a little bit of helium. So the material between the stars is the same type of material that the stars themselves are made out of. But if we could take a sample, in other words, if we could go out between the stars and scoop up a little bit of the material, the density, or how many atoms there are, how close together they are, is actually quite thin. You would have only 1 atom per cubic centimeter. Now, a cubic centimeter is about half the size of a sugar cube. So imagine a little box about half the size of a sugar cube, and imagine only 1 atom being inside of that box. That's not a perfect vacuum. A perfect vacuum would be 0, no atoms, but 1 atom per cubic centimeter is actually very, very close to being empty. So the material between the stars is very thin. There's not a lot of it there, but what is there is in the form of gas, and the gas that is there is mostly hydrogen and helium. Now, what about the dust? This is a photograph of the Milky Way galaxy, and this is what you would see here on Earth if you were outside on a nice dark night taking a picture of the sky. And what I want you to notice is the Milky Way seems to have a lot of things going on. You can see lots and lots of stars. Think about how these many, many little individual white dots, these are all stars. Lots of stars right here, more stars than you'd ever want to count in your lifetime. But for almost 2,000 years, arguably, there has been some confusion about this dark stuff. In the old days, in the early days of the Greeks and later the Romans, this was believed to be an empty place. This was sometimes called the Great Void of the Milky Way, because it seems like there's nothing there, or very little bit. Lots of stars there, and it seems like not many stars there. So it was believed that this was just a gap, or an empty place in our galaxy. But what we now know is all of this dark stuff that you see here is actually dust. And when I say the word dust, I'm referring to the size of the particle. A grain of dust is about the size of a smoke particle. You would need a microscope to be able to see it. It is so very, very small. Don't think of the word dust related to your home. If you are dusting in your house and sweeping up whatever is on the back of your TV set, that is obviously something very different. It's hair follicles and pet dander and all sorts of things. So we're really referring to the size of the particle. And 1 grain of dust is usually composed of a bunch of atoms, and those atoms are typically carbon, oxygen, and silicon atoms. And here's a computer model of what these grains would look like. So think of that, this one single collection of atoms is a grain of dust. Here is a different grain of dust, and each of these little circles represents an atom, and the atom could be carbon, oxygen, or silicon. So these are microscopic. It would require a microscope to see them, but there's so much of this dust between the stars that it makes it so that it blocks the light of the stars behind it. And so this interstellar dust is actually kind of even more sparse than the gases. It's 1 grain of dust per 10 cubic centimeters. Now, one last picture I want to show you. Here's a wonderful picture of just a general region of our galaxy where you can see lots and lots of stars. But notice the dust. The dust does not make visible light. It doesn't glow with visible light. What the dust does is it blocks visible light. And so these giant clouds of dust are blocking the light of the stars from behind it, so we can't see those too well. So the material between the stars is in the form of gas as well as in the form of dust, and it is ultimately this gas and the dust that becomes the stars and the planets that go around the stars. In the next video, what we're going to talk about is how you can take these giant clouds of gas and dust and turn them into stars with planets going around them. But we'll save it for the next video. I hope you'll join me.